In previous class, I derived an equation to find EMF of hydrogen concentration cell. That is, E cell is equal to 0.059 into pH of anode minus pH of anode means pH of solution in the anode option pH of solution in the cathode option plus 0.059 by 2 into log pressure of hydrogen in anode option by pressure of hydrogen in the cathode option. So this is the equation we have to remember to consume to save time. Right? Now, for example, platinum solid hydrogen gas H plus ion concentration in the solution is 10 power minus 6 molar. This is 1 atmosphere. And H plus ion concentration in the cathode option is 10 power minus 4 molar. Hydrogen gas 1 atmosphere. Platinum solid. Okay. Now, instead of writing reaction at anode, reaction at cathode, net cell equation, so to avoid all those steps, I gave this equation. E cell equal to 0.059. pH in pH of solution, the anode option, minus pHc, pH of solution, the cathode option, plus 0.059 by 2 log pressure exerted by hydrogen gas in the anode option by pressure exerted by hydrogen gas in the cathode option. Okay, right. Now find out pH of anode. pH of solution in the anode option it is 6. pH of anode solution in the cathode option it is 4. Right. Now 1 atmosphere, there is no need to take, even though we will substitute, I will show you. E cell is equal to 0.059, pH of solution in the anode option 6, pH of solution in the cathode option 4, plus 0.059 by 2 log pressure of hydrogen in the anode option, in the cathode option, log 1 value 0, it becomes 0. So final answer 0.059 into multiply this, so you get in the answer volts. Like this, we have to solve the problem. But remember this equation for hydrogen electrode E cell equal to 0.059 pH of solution in the anode option minus pH of solution in the cathode option plus 0.059 by 2 log pressure of hydrogen in the anode option by pressure of hydrogen in the cathode option. Then we can calculate easily in less time. Now let us see some more problems, some more models on hydrogen concentration cells. platinum solid, hydrogen gas 1 atmosphere, sodium hydroxide solution 10 power minus 4 molar. Next, H plus ion concentration 10 power minus 5 molar. Hydrogen gas 1 atmosphere pressure, platinum solid. Now, here in anode of cell, solution is aqueous solution of sodium hydroxide. So, does it behave as electrode? Any element is in contact with its own ions act as a half cell. Now here, hydrogen is in sodium hydroxide solution. Does it behave as electrode? It behaves as electrode because it is 10 power minus 4 molar sodium hydroxide. That means OH minus ion concentration is 10 power minus 4 molar. Hydrogen ion concentration in the solution is ionic product of water by OH minus concentration. So therefore, 10 power minus 14 by 10 power minus 4. This is 10 power minus 10 molar. So therefore, pH of the solution is 10. So concentration of hydrogen ions in the solution is negligible, 10 power minus 10 molar only. But few H plus ions are there. So hydrogen molecules are in contact with H plus ions. Few H plus ions in the sodium hydroxide solution. Therefore, it acts as electrode. Now, pH of solution in the anode of cell is 10, and the hydrogen ion concentration is 10 power minus 5 molar in the cathode of cell. So, pH of solution in the cathode of cell is 5. Hydrogen active mass is 1 in cathode of cell. Active mass of hydrogen in the anode of cell is also 1. So therefore it becomes 0. So formula becomes E cell is equal to 0.059 pH in the anode of cell minus pH in the cathode of cell. So E cell is equal to 0.059 into 10 minus 4, that is 10 minus 5, that is 5. This is the answer. Clear? Now, going to another problem. Platinum solid, hydrogen gas, 1 atmosphere pressure, KOH, 10 power minus 3 molar. Next, sulfuric acid, 0.05 molar H2 gas, 1 atmosphere pressure, platinum solid. Right? Now, here active mass of hydrogen in anode half cell and cathode half cell is 1. So, then formula will be E cell equal to 0.059 pH of solution in anode half cell minus pH of solution in the cathode half cell. Now see, pH anode half cell, it is POH is 3, pH is 11. In case of H2SO4, see, hydrogen ion concentration in the solution is 2 into 0.05 molar because 1 mole sulfuric acid produces 2 moles of H plus ions in the solution. So it is 10 power minus 1 molar. This is 1. Right? Now, therefore, 0.059 11 minus 1. Simplify it, you will get the answer. Next question. Platinum solid hydrogen gas 1 atmosphere cesium hydroxide 10 power minus 3 molar and acetic acid 10 power minus 2 molar pKa is 4.74. Hydrogen gas 1 atmosphere platinum. So this is representation of the cell. Now POH is 3. So therefore pH of solution in the anode compartment 11. But in cathode half cell acetic acid is a weak acid. So therefore, what is the formula used to calculate pH of weak acid? Apply the formula pKa minus log C by pKa minus log C by 2. So 4.74 minus log 10 power minus 2 by 2. So 4.74 plus 2 6.74 by 2 3.37. So this is pH of the solution in the cathode half cell. So pH of solution in the anode we have and pH of the solution in the cathode half cell we find out. So therefore you can apply the formula E cell is equal to 0.059 into pH of solution in the anode half cell minus pH of the solution in the cathode half cell. Then you will get the answer because here in anode half cell and cathode half cell active mass of hydrogen is 1 only. Right? PT solid hydrogen gas 1 atmosphere pressure H2O HCl 10 power minus 3 molar H2 1 atmosphere pressure platinum solid. Right? Now see here hydrogen gas is in contact with water in the anode half cell. Does it behave as electrode? Yes, it behaves as electrode because pure water undergoes self-ionization. The self-ionization of pure water can be represented by H2O gives rise to H plus OH minus. So at 25 degrees Celsius, concentration of H plus ions in the pure water is 10 power minus 7 molar, and concentration of OH minus ions also the same. So pH of pure water is 7. So this is pH of electrolyte in the anode half cell, and HCl concentration 10 power minus 3 molar. So therefore pH is 3. So this is pH of cathode half cell. Now 0.059 into 7 minus 3, 0.059 into 4. So this is the answer. Platinum, hydrogen gas, 1 atmosphere pressure, rubidium hydroxide, 10 power minus 3 molar, ammonia, 10 power minus 2 molar, pKb is 4.74, hydrogen gas, 1 atmosphere, platinum solid. So in this problem also, active masses of hydrogen gas in both anode half shell and cathode half shell are one only, so there is no need to take. Just use E cell equal to 0.059 into pH of solution in the anode half shell minus pH of the solution in the cathode half shell. See here, POH is 3, pH is 11. This is pH of solution in the anode half cell. Next, ammonia. Ammonia is a weak base. Ammonia is weak base. So what is the formula we use to calculate pH of weak base? First step, we have to find out pOH. pOH equal to pKb minus log C by 2. So pOH equal to 4.74 minus log C, log 10 power minus 2 by plus 2, 2. So it is 3.37, and pH equal to 14 minus 3.37. So you calculate pH of the solution in the cathode half cell, and after that use the formula 0.059 pH of solution in the anode half cell minus pH of the solution in the cathode half cell. Right? Platinum solid, hydrogen gas, 1 atmosphere pressure, NH4Cl 0.1 molar plus NH4OH 0.2 molar, pKb of ammonia is 4.74, salt bridge. Next, CH3COONA 0.1 molar plus CH3COOH 0.01 molar, and pKa of acid is 4.74. Then hydrogen gas, 1 atmosphere pressure, platinum. So this is cell representation. in anode half cell and cathode half cell, active mass of hydrogen electrode is 1 only. So there is no need to take. Simply you can use the formula E cell is equal to PHA minus PHC. Right? Simple formula. But here examine carefully. NH4Cl is a salt. NH4Cl salt, it is a salt of ammonia and HCl. Ammonia and HCl. Ammonia is weak base, HCl is a strong acid. Therefore, ammonium chloride is a salt of weak base and strong acid. And ammonia is a weak base. Okay. So, it is nothing but mixture of weak acid and it's a salt with strong base. So therefore, this solution is nothing but basic buffer solution. Basic buffer solution. Now observe the electrolyte in the anode half cell. Sodium acetate. It is salt of weak acid, acetic acid and sodium hydroxide. CS3COOH acetic acid, sodium hydroxide is a strong base. Therefore, it is a salt of weak acid and strong base. Next, CS3COOH weak acid. So, means in cathode half cell, solution is nothing but mixture of weak acid and it's a salt with a strong base. Therefore, this solution is an acidic buffer solution. Now, what is the formula we use to calculate pH of a buffer solution? In case of basic buffer solution, we use the Henderson equation POH equal to PKB plus log salt concentration by base concentration. POH equal to 4.74 plus log salt 0.1 by 0.2. And you simplify this is POH, you will get 4.74 plus log 1 by 2. So log 1 by 2 is nothing but log 0.5. Log 5 value 0.6990 and take characteristic and simplify it and then pH in the anode half cell calculate like this 14 minus POH. This is the procedure to calculate pH of solution in the anode half cell. Next, in cathode half cell, directly acidic buffer solution is there. Use this formula pH equal to pKa plus log concentration of salt by concentration of acid. Then here pKa of acid is given 4.74 plus log salt concentration 0.1 and acid concentration 0.01 and you simplify this, you will get pH of solution in the cathode half cell. After that, you do finish the problem like this 0.059 substitute pH of solution in the anode half cell and pH of solution in the cathode half cell. You will get the answer. Platinum solid hydrogen gas 1 atmosphere pressure CH3 COONA 10 power minus 2 molar pKa of acid is 4.74 salt bridge 0.2 molar, pKb is 4.74. This is ammonia pKb and this is acetic acid pKa, hydrogen gas, 1 atmosphere pressure, platinum solid. So this is the representation of the cell given. Concentration cell, both are hydrogen electrodes. Active mass of electrode in cathode half cell and anode half cell same and equal to 1. Therefore, you can apply the formula E cell is equal to pH of solution in the anode half cell, pH of the solution in the cathode half cell. This into 0.059. Right? Now, in anode half cell, sodium acetate. Sodium acetate is a salt of weak acid CS3COOH plus NaOH. So it is nothing but a salt solution. In salt solution also we have either H plus ions or OH minus ions in the solution. It is salt of weak acid and strong base. So therefore solution naturally it is basic solution. But in ionic equilibrium topic we derived the equation to find out pH of the salt solution. What is the formula used to calculate pH of salt solution? pH is equal to 7 plus half pKa plus half log C. This is the formula used to calculate pH of salt of weak acid and strong base. So it is a 7 plus half pKa value 4.74 plus half into log salt solution concentration 10 power minus 2. Now you will get the pH of solution in the anode half cell. Clear? Now in cathode half cell NaH4NO3 is there. Ammonium nitrate solution is there. Ammonium nitrate, it is a salt of ammonia and nitric acid. So it is a salt of weak base and strong acid. In this solution also H plus ions and OH minus ions are there in the solution. Naturally acid is strong, therefore it is acidic solution. Solution contains H plus ions. And how to find out the pH of this salt solution? pH of salt of strong acid and weak base is 7 minus half pKb minus half log C, where C is the concentration of the salt. This formula we derived in ionic equilibrium. Now it is 7 minus half 4.74 minus half log 0.2. Right? So find here pH of solution in the cathode half cell and substitute these two values in this equation. You will get the EMF the cell. Platinum, hydrogen gas, 1 atmosphere pressure, CH3, COO, NH4, ammonium state, pKa of acetic acid is pK of acetic acid is pKb of NH4OH is 4.74. CH3COO Na 10 power minus 3 molar. H2 gas 1 atmosphere pressure platinum solid. Right? So this is a concentration cell. Now in anode half cell and cathode half cell, electrode is at 1 unit concentration, or you can say active mass is 1, right? Now in anode half cell, ammonium state is there. What is the nature of ammonium state? It is a salt. It is salt of a weak acid CH3COOH and a weak base ammonia. Okay. Now pKa of weak acid and pKb of weak base are exactly same. Therefore, pH of the solution is exactly 7. It is a neutral solution. For example, for other salts of weak acid and weak base, to find pH, you have to use this formula 7 plus half pKa minus half pKb. So this is the formula we have to use to find pH of salt of weak acid and weak base in the aqueous solution. So pKa value, pKb value both are equal. So therefore H plus ion concentration, OH minus ion concentration are same, and at 25 degrees Celsius it is a neutral solution, therefore pH is 7, or it is you can calculate from this also. Now sodium state already discussed in the previous problem, how to find out pH of salt of strong acid and weak acid and strong base, that is pH equal to 7 plus half pKa plus half log C, right? So by using this equation, you find pH of the solution in the cathode half cell. By using this equation, you find pH of solution in the anode half cell, and then calculate E cell value 0.059 into pH A minus pH C. Okay. So these are some of important models in concentration cells. Now let us see one more problem, but it is not on hydrogen electrode. Simple problem on silver electrode. Ag solid to Ag plus 0.1 molar, then salt bridge, Ag plus concentration 1 molar and Ag solid. So this is the cell representation given, right? Now how to find the EMF of the cell? Now write down first reaction at anode. What is the reaction at anode? Oxidation of reaction, Ag plus electron. This is a concentration cell. So write 0.1 molar here. And reaction at cathode. What is the reaction at cathode? Ag plus electron gives rise to Ag. Here Ag plus ion concentration is 1 molar. Now, what is the net cell equation? Net cell equation. Silver, active mass is 1. Cancel the electrons. So, Ag plus 1 molar gives rise to Ag plus 0.1 molar. Now, apply Nernst equation. E cell, E naught cell is 0 for any concentration cell, minus 0.059 by number of electrons involved 1 and log Ag plus concentration 0.1, or you can write 10 power minus 1 by 1. So this is 0.059 volts. So for any concentration cell or for any galvanic cell, you have to follow this procedure. Always write reaction at anode. Next, reaction at cathode. Next, before adding those two half reactions, you have to check the number of electrons. Number of electrons, whether they are equal or not. Suppose number of electrons in both the half reactions are not same, then remember that you have to equalize the number of electrons in both the half reactions. Right? Next, see one more question. Pt solid, chlorine gas, 1 atmosphere, Cl minus 10 power minus 2 molar, salt bridge, Cl minus 10 power minus 3 molar, chlorine gas, 1 atmosphere, and platinum solid. Right? Here, chlorine electrodes are at 1 atmosphere pressure, therefore active mass is 1. Even though, first write the reaction at anode. What is the reaction at anode? Oxidation of reaction. Therefore, 2Cl minus, or you can write Cl minus because electrode potential values are intensive properties, right? No need to take 2 also because we have to cancel that. Cl minus gives rise to half Cl2 plus electron, and reaction at cathode, reduction reaction, is it not? Half Cl2 gives rise to net equation. You can cancel off Cl2 and electron. Now Cl minus in the anode half cell gives rise to Cl minus in the cathode half cell. Now apply Nernst equation. E cell equal to E naught cell for concentration cell, it is 0 minus 0.059 number of electrons involved 1 and log Cl minus in the cathode half cell 10 power minus 3 and Cl minus in the anode half cell 10 power minus 2. Therefore, it is 10 power minus 1 minus into minus plus log 10 value 1. So, therefore, it is 0.059 volts. Remember, anode Cl minus gives rise to Cl2 minus 1 0. So, it is oxidation of reaction. At anode, oxidation of reaction, cathode, reduction of reaction takes place. Platinum, chlorine gas at 2 atmosphere pressure, Cl minus concentration 10 power minus 2 molar. Here you take 1 atmosphere. It is Cl to 1 atmosphere. Cl minus concentration is 10 power minus 2. Cl minus concentration take 10 power minus 3 molar. And here you take 2 atmospheres. Right? Now, this is a concentration cell. Here, electrode is not at unit mass, remember. So, therefore, at anode, what is reaction at anode? Cl2. Here, you can take Cl2, not of Cl2, because chlorine active mass is not equal to 1. Therefore, take Cl2 and 0 to minus 1. So, oxidation of reaction we have to write oxidation of reaction. So, 2Cl minus gives rise to Cl2 plus 2 electrons. To differentiate here, I am writing A means in the anode, here also anode and cathode Cl2 plus 2 electrons gives rise to Cl minus in the cathode half cell. Now, you can cancel only number of electrons. 2Cl minus in the anode half cell plus Cl2 in the cathode half cell gives rise to Cl2 in the anode half cell plus 2Cl minus in the cathode half cell. Now, E cell is equal to E naught cell 0 minus 0.059 by number of electrons involved to log product of concentration of products Cl2 gas in the anode half cell into Cl minus concentration square in the cathode half cell by chlorine in the cathode half cell into Cl minus concentration in the anode half cell square. So it is E cell is equal to minus 0.059 by 2 log chlorine active mass in the anode half cell 1 atmosphere and Cl minus concentration square in the cathode half cell. So 10 power minus 3 square. So it is 10 power minus 6 by chlorine active mass in the cathode half cell. So it is 2 atmospheres, 2 Cl minus concentration in the anode half cell. It is 10 power minus 2. So 10 power minus 2 square, 10 power minus 4. So you simplify this, you will get EMF of the cell. See one more model, CR, CR3 plus 0.1 molar, Fe2 plus 0.01 molar, Fe. So this is a cell, a galvanic cell, but it is not a standard cell. Chromium is in Cr3 plus solution and iron is in iron 2 plus solution. Concentrations not same, so it is not a standard cell. And here information is E naught of Cr3 plus 2 Cr is minus 0.74 volts. E naught of Fe2 plus 2 Fe is minus 0.44 volts. This is given information. Given information. Now we have to find the EMF of the cell. Now we have to follow the systematic procedure to find the EMF of the cell by using Nernst equation. We require net cell equation. To get net cell equation, first step you have to write the reaction at anode and reaction at cathode and then net cell equation. So first write the reaction at anode. Cr to Cr3 plus, Cr to Cr3 plus 3 electrons. Now reaction at cathode. Reaction at cathode, reduction of reaction. Fe2 plus ions are there in the solution. 2 electrons gives rise to Fe. So this is reaction at cathode. Next step, you must check the number of electrons involved in both the off reactions. At anode 3 electrons are involved, at cathode 2 electrons are involved. You have to equalize the number of electrons in both the off reactions. To equalize the number of electrons in both the off reactions, multiply the equation with 2 and multiply the second equation with 3. So then what is the net cell equation? Net equation is 2Cr plus 3Fe2 plus gives rise to 2Cr3 plus and 3Fe. See here, no need to take chromium and iron because their active mass is 1. Now E cell is equal to E naught cell minus 0.059. How many electrons are involved in this equation? 6 electrons, and log Cr3 plus concentration square by Fe2 plus ion concentration power 3. So how to find E naught cell? E naught cell is equal to E naught cathode minus E naught anode. So E naught cathode, it is given minus 0.44, minus E naught anode value, it is given minus 0.74. So it is 0.30 volts, right? This is EMF of the standard cell actually. Now you can substitute here E cell equal to E naught cell 0.30 volts minus 0.06. You can take approximately. Here you can take 0.06 by 6. So you approximate this as 0.01, right? 0.06 by 6. 0.06 by 6 is how much? 0.01, is it not? So log Cr3 plus concentration 10 power minus 1, Cr3 plus concentration. So 10 power minus 1 square, Fe2 plus concentration 10 power minus 2. So 10 power minus 2 power 3. So 10 power minus 6, 10 power 6, 10 power minus 2, 10 power 4, 4 log 10, so 4. Is it not? So you simplify this equation, you will get EMF of the cell, right? So in next class, we will do some more problems on Nernst equation. Nernst equation is very important for you in both mains level and advanced level exam. In advanced level, definitely it is very important. In mains and advanced, definitely you will get more than